I hope you are doing well. Okay, so today we are going to look at a very important topic. And today we are going to look at polygons. Polygons. Okay, so when we talk about polygons, what we mean by polygons is that we are talking about any closed plane figure bounded by line segment. Any closed plane figure bounded by line segment. For a figure to be closed, at least you need 3 lines for a figure to be closed. Okay, so you need at least 3 lines, three lines. Okay, so what it means is that a polygon is any figure bounded by 3 or more straight lines. So any closed plane figure bounded by 3 or more straight lines. Okay, so when you take something like a triangle, okay, so this is a closed plane figure. It is bounded by 3 lines. So this is a type of polygon. So what it means that triangles are also what types of polygons, or they are polygons. Okay, when you take any 4-sided figure like this, okay, like this, okay, so this is a square. Okay, this is a kite, this is a parallelogram, and this is a trapezium. Okay, trapezium. Okay, so these are 4-sided plane figures, and they are also types of what? They're also types of polygons. Okay, but in general, all these 4-sided plane figures, we are going to call them quadrilaterals or 4-sided figures, and then triangles for what? For 3-sided plane figures. Okay, then we move on to what you already know from JHS, which is a 5-sided. So a 5 sides, if a polygon has 5 sides, it will be called what? A pentagon. Okay, if it has 6 sides, it's going to be called hexagon. Okay, so 7 sides is going to be called heptagon. 8 will be what? Octagon. 9 will be what? Nonagon. 10 will be what? Decagon. 11 will be ondecagon. 12 duodecagon. So we are going to end at 12. Okay, so for an n, let's say we don't know the number of sides, we are going to call it an n-sided what? Polygon. An n-sided polygon. Okay, so we are going to look at certain properties of polygons. The first thing we are going to look at is the sum of interior angles. Okay, so let's say we have what we call a triangle, which is also a polygon. We know that the sum of interior angles of a triangle, we've been able to prove that it's equal to what? 180 degrees. So let's say if you have an equilateral triangle, and this is 60, this is 60, and this is 60. Okay, it's going to give us 180 degrees. Okay, now we are going to use the sum of interior angles of a triangle to be able to determine the sum of interior angle of any polygon we are given. Okay, so let's say you are given a square. A square has how many sides? 4 sides. Now I want you to take note of the sides and the number of triangles we can create from the plane figure we are given. So the square has 4 sides. Okay, now to be able to create a triangle from the square, you need to draw a line from vertex to vertex. Remember that the lines must not cross. Okay, so I can draw a line from this side to this side, and I'll create two triangles. Okay, one triangle, two triangles. Okay, so for four sides, I have two triangles. Okay, so what it means is that the sum of interior angles, sum of interior angles is going to be equal to the number of triangles, which is 2 times 180, which is going to give us what? 360 degrees. Okay, so remember that for four sides, we had what? Two triangles. Okay, how about a five-sided polygon or a pentagon? A five-sided figure or a pentagon. So for a pentagon, remember we are drawing lines from vectors to vectors without the lines crossing. Okay, so I can draw this and this. Okay, so that I have 1, 2, 3 triangles. Okay, so 5 sides, 3 triangles. Okay, so the sum of interior angles is going to be equal to 180 times the number of triangles, which is going to give us what? 540. Okay, 5 sides, 3 triangles, 4 sides, 2 triangles. How about a 6-sided figure or a hexagon? Okay, so this had 6 sides. Okay, so let's try and draw the triangles and see. Remember, vectors to vectors, the lines must not touch each other. So I can draw a line this way, I can draw another line this way, then I can draw a third line. So I have 1, triangle 2, triangle 3, triangle 4. Okay, so 6 sides, I have 4 triangles. Okay, 6 sides, 4 triangles. Now we see a pattern. For the first one, we had a square. It was 4 sides, 2 triangles. We had 5 sides, so it was 3 triangles. And we had 6 sides, 4 triangles. Okay, so we can see a relationship between the number of sides and the number of triangles. Okay, so if n is the number of sides, okay, realize that for all the examples we did, the number of triangles was 2 less than the number of sides. Okay, so when we had 4, the number of triangles were what? 2. Okay, when we have 5 sides, the number of triangles we had what? 3 triangles. We had 6 sides, 4 triangles. Okay, so this is going to work for every other polygon. The number of sides is going to be 2 more than the number of triangles, or the number of triangles is going to be 2 less than the number of sides. Okay, so to determine the number of triangles is going to be what? N minus what? 2. To find the sum of interior angles, we just need to multiply the number of triangles by what? 180 degrees, because you know that one triangle is equal to what? The sum of interior angles of one triangle is equal to what? 180 degrees. Okay, so we've been able to come up with a formula to be able to determine the sum of interior angles of what? A polygon. So for any polygon, the sum of interior angles, the sum of interior angles, okay, will be equal to n minus 2, which is the number of what? Triangles, times what? Times 180. Okay, so the n is equal to what? The number of sides. Okay, do you get it? Okay, so let's say you are told to calculate the sum of interior angles of a hexagon. Sum of interior angles of a hexagon. Okay, so you need to know the number of sides of hexagon. Hexagon has how many sides? It has 6 sides. Okay, so the sum of interior angles is going to be equal to what? N minus 2, okay, times 180. Okay, so it's going to give us 6 minus 2 times 180, which is the same as what? 4 times 180, and this is going to give us what? 720 degrees. Is that clear? Yes. So now we're going to look at how to find each interior angle of a regular polygon. So we are finding interior angles of regular polygon. Okay, when we talk about a regular polygon, what we mean by a regular polygon is any polygon in which all the sides are equal. So all sides are equal, and then as well all interior angles are equal. So all sides are equal, all interior angles are equal. An example of regular polygon is an equilateral triangle. So all the sides are equal, all the angles are equal, which is what? 60 degrees in each angle. Another example is what we call a square. Okay, so if you have a square, all the sides are equal, then what? All the angles are also what? Equal, which is what? 90 degrees. Yes. So for any other regular polygon, we are just going to say a regular pentagon, a regular hexagon, a regular octagon, a regular nonagon. Okay, so if you have a pentagon, for example, a regular pentagon, so let's say this is a regular pentagon, not drawn to scale. Okay, or how many interior angles is it going to have? 1, 2, 3, 4, 5. So 5 sides, 5 what? Interior angles. Okay, so normally, always, the number of interior angles is equal to the number of sides. Okay, so if you are told to find the measure of each interior angle, okay, first we need to find the sum of interior angles, which you know that the sum of interior angles of any polygon is equal to n minus 2 times 180. This will give us the sum of interior angles. Okay, but since all the interior angles are the same, okay, means that we are going to divide the sum of interior angles by the number of what? Interior angles. Okay, remember that the n is the number of sides, and the number of interior angles is always equal to what? The number of what? Sides. So to find the interior angle, the interior angle is equal to the sum of interior angles, which I've already written, all over the number of sides. Okay, yeah, so the sum of interior angles over the number of sides, and this is going to give us our formula for what? Interior angle. Finding the interior angle of what? A regular polygon. Okay, so we are going to use this formula. Take note of this formula, very important. Okay, now we're going to look at exterior angle. Okay, so when you have, say, an equilateral triangle like this, okay, I'm just trying to get the exterior angles. That's why I've extended the lines. Okay, for an equilateral triangle, okay, the interior angles are what? 60 degrees, 60 degrees, and 60 degrees, so that it will add up to what? It's going to add up to what? 180 degrees. Okay. Now, what will be the exterior angle here? Remember, angles on a straight line add up to 180 degrees. So this is going to give us 180 minus 60, which is what? 120. The exterior angle also formed there is also going to be equal to what? 120. And the exterior angle formed there is going to be equal to 120. Sorry. So if you add the exterior angles, it's going to be 120 plus 120 plus 120. It's going to give us what? 360 degrees. The exterior angles are going to add up to 360 degrees. If you have a square too, if you have a square too, okay, so let's say a square. I'm going to draw these to be able to give me the exterior angles. Okay, so let's say this is my square. Okay, this is my square. I don't need this side. Okay, this will be my so for a square, the interior angle is equal to what? 90 degrees. Okay, so you have 90, 90, 90, and then 90. Okay, the exterior angle formed here is also going to be what? Remember, angles on the straight line add up to 90 degrees, add up to 180, so it's going to be what? 90 degrees here, 90 degrees here, 90 degrees here, and then 90 degrees here. Okay, so if you want to find the sum of interior angles, it's going to be what? 90 plus 90 plus 90 plus 90, which is also going to give us what? 360 degrees. Okay, sorry. This will work for any other polygon. Okay, so it has been found out, it has been proven that the sum or the exterior angle here, the sum of exterior angles, if we add all the exterior angle of any polygon, is going to give us what? It's going to give us what? If you add all the exterior angles, okay, if you add all the exterior angles of a polygon, it's going to give us 360 degrees. Okay, yes, but if you are told to find the measure of each exterior angle of a regular polygon, okay, now the number of exterior angles of a regular polygon is also the same as the number of sides of a regular polygon. If you want to find the exterior angle, the measure of the exterior angle of any regular polygon is going to give you the sum of exterior angles, which is equal to 360 all over the number of sides. After that, the number of sides is always equal to what? The number of exterior angles. So it's going to give us 360 over n. Okay, so if you are told to find the exterior angle of, let's say, a square, the exterior angles of a square. Okay, we know that the square has 4 sides, so the exterior angle is going to be equal to what? 360 over 4, which is going to give us what? 90 degrees. Okay, so take note of the formula we've already seen. The sum of interior angles will be equal to what? N minus 2 times 180. Okay, the interior angle of a regular polygon is going to be n minus 2 times 180 over n, and then the exterior angle of a regular polygon is going to be 360 degrees over n. So take note of this. We are going to use this to solve all of the examples in our book. Thank you.